This is the mini lesson for 2.5. The distance d in miles a runner runs varies directly with the amount of time t in hours spent running. Suppose Antonio's constant of proportionality is 9. It tells me to write an equation that represents the relationship between the distance ran, this is first, and the time spent running. Assume the runner can maintain the same rate of running. So my constant is 9 over 1, and that is equal to the distance in miles a runner runs varies directly with the amount of time. So this is the distance, which is d. This is the time. So it wants me to turn this into an equation. I'm going to use means and extremes. 1d equals 9t. Here's my equation. So it says name the constant of proportionality and describe what it represents in this problem. So naming it, they already told me that the constant, which remember we're going to call that k, is 9. So what does it represent in this situation? Remember, I'm always going to basically put 1 in place of the variable that's with the constant. So I'm going to say for every 1 hour spent running, Antonio runs 9 miles. So if I plug a 1 in place of t, and t is my hours, if I then did 9 times 1, my distance would be 9. So now it tells me to complete the table to show the amount of time spent running and the distance run. Use the equation you wrote. So I'm using this equation, d equals 9t. I'm just going to rewrite it over here. So if t is 0, 9 times 0, my distance would be 0. If t is 0.25, 9 times 0.25 is 2.25. I'm going to do all of these first. If my time is 0.75 times 9, I get 6.75. Or I could see this times 3 is this times 3 is this. 1.25 times 9 is 11.25. 1.5 times 9 is 13.5. So now to get these other answers here, I could still use my equation, but now this is my distance. So if I put a 4.5 here, 4.5 equals 9t. So I divide both sides by 9. So 4.5 divided by 9, I would get an answer of 0.5. Oops, sorry, that goes right up here. So right here, it would be 9 equals 9t. This one's easy. Divide both sides by 9, and I get 1. Then down here, 18. If I plug 18 equals 9t, isolate the variable, divide both sides by 9, I get 2. So now we've plotted all the points. As you know, when two quantities vary in such a way that the ratio of the quantities is constant, the two quantities are directly proportional. You can also determine if two quantities are directly proportional by analyzing the plotted points on a coordinate grid. Graph the values in the table that we completed. So we're going to use those points that were on the previous page. So one point was 0, 0. The next one's 0.25, and then 2.25. So I have to watch these intervals because this would be 3. So 2.25 is just a little bit up. 0.5 and 4.5. and then 0.75, 6.75, which is going to be close to 7. And then I have 1 and 9. That's an easy one. 1.25 and 11.25. 1.5 and 13.5. And 2 and 18. Okay, so now all those points are plotted. So what do I notice about the points on the graph? I notice that they would make a straight line. Also noticing it goes through the origin. So would it make sense to connect the points on the graph? Why or why not? So we're talking about time and distance. So already I see here we have half. So I know time, I can have parts of an hour. Now I'm trying to figure out distance. And yes, it is possible for me to run 1.5 miles. So it would make sense for me to connect. So I am going to do so. And I'm going to say yes, because I can have fractions of time and distance when running. Interpret the point of 0, 0 on the graph. Well, if I look at those labels, it would mean if I've been going for 0 hours, he would go a distance of 0. So 0 hours and 0 distance. So remember, this is x, this is y, so I'm really looking at x-axis and then the y-axis labels. So interpret the meaning of 1.5, 13.5. It means after 1.5 hours, Antonio would have run 13.5 miles. So again, I'm grabbing those labels right for my x and y axis. So remember the graph of two variables that are directly proportional, or that vary directly is a line that passes through the origin. Remember, it's also straight. Okay, question 5. For each of the points on the graph, write the ratio in the form of y over x. Then simplify. So I'm writing 2.25 over 0.25. And when I divide those out, 2.25 divided by 0.25, I get 9. And I can do that for all of these. This gives me 9. We're going to change this number to 6.75. Every time when I divide these out, I'm getting 9. And remember, I'm writing y over x every time. So explain your conclusion from question 5. What do we notice? I notice that y over x equals my constant. This was the constant in our problem. So y over x equaled 9 every time. So when analyzing the graph of two variables that are directly proportional, the ratio of the y to the x for any point is equivalent to the constant. This will always be the case. So whenever you see a graph that's straight and through the origin, we know it as a constant. We know that any y coordinate over the equivalent x coordinate is going to give me the constant. Now they're asking, why do I think 0, 0 was not included? And this would be the reason I would say that 0, 0 would not be equal to my constant of 9. So that would be the only point that we couldn't use to prove it. So here, I'm just going to start this one, then you're going to finish this on your own. So it says locate the point 1,9 and 1.513 on your graph. So you guys are going to look at your graph. What is the horizontal distance from left to right from 1 to 1.5? So if I look at this, from 1 to 1.5, that's a distance of 0.5. And then the vertical distance of 9, so if I start at 9 and I go to 13.5, that would be a distance of 4.5. So I'm going to write 4.5 here. So now what's the ratio of vertical, that was the 4.5, to horizontal, 0.5. If I divide 4.5 by 0.5, I get that constant again. You're going to see that that's going to happen again. I can take any 2 points, and when I take the vertical distance over the horizontal distance, which remember, vertical is my y-axis, so it's just like taking y over x, but I can also take the distance between them, and I will always get 9. So you could finish with this, and then you can test any 2 points you want here, and then you can continue with the lesson.